witnessed the birth of a superpower as high-precision laser beams forged the very foundation of the Fattah 2 using advanced aerospace-grade titanium powder technology. This intricate process uses direct metal laser sintering to create complex geometries that traditional manufacturing simply cannot achieve, ensuring maximum structural integrity at high speeds. Inside this state-of-the-art facility, so a massive fleet of industrial printers works tirelessly to build the components of the world's most advanced hypersonic flight systems. A robotic arm carefully extracts the finished fuselage section, still glowing with the residual heat of its creation, marking the completion of the primary structure. The cooling process is critical, using liquid nitrogen to rapidly stabilize the molecular structure of the titanium alloy, preparing it for the extreme stresses of Mach 15. Every particle of excess material is removed, leaving behind a perfectly formed shell that serves as the exoskeleton for this incredible piece of hypersonic engineering. Ultrasonic waves are utilized to polish the surface to a microscopic level of smoothness, drastically reducing air resistance during the missile's high-velocity flight through the atmosphere. The result is a seamless aerodynamic masterpiece of metallurgy, ready to house the powerful heart that will drive it toward its distant strategic targets. We now enter the engine assembly phase, where the heart of the Fattah 2 is brought to life using cutting-edge robotics and precision engineering techniques. The installation of the bell-shaped vector nozzle requires micrometric precision, allowing the missile to maneuver with incredible agility even while traveling at hypersonic speeds. In this sterile environment, expert technicians monitor every movement to ensure that no contaminants compromise the complex internals of the solid-state rocket propulsion system. Advanced chemical etching creates a network of microscopic cooling channels, essential for managing the intense heat generated by the massive thrust of the primary engine. These channels will carry coolant to protect the engine structure, allowing it to withstand temperatures that would melt conventional metals in a matter of seconds. The propellant loading begins as a high-energy polymer fuel is poured into the casing, which will eventually solidify into a powerful and stable energy source. This two-stage solid fuel configuration is designed to provide the massive acceleration needed to push the Fattah 2 beyond the Mach 15 velocity threshold. Every inch of the engine is scanned by high-resolution 3D lasers, detecting even the smallest microcracks that could cause a catastrophic failure during the flight. The scanning data is processed by advanced algorithms to verify the structural integrity of the engine, ensuring it meets the rigorous standards of hypersonic performance. With the propulsion system verified, the heart of the missile is ready to be integrated into the main body, bringing us closer to a complete weapon. Next, we move to the electronics lab, where the digital brain of the Fattah 2 is assembled using ultra-fast automated component placement systems. These high-speed processors are the core of the guidance system, capable of performing millions of calculations per second to maintain a precise flight path. Under the microscope, gold-plated connections ensure maximum conductivity and reliability, protecting the sensitive electronics from the extreme vibration and heat of launch. The inertial navigation sensors are installed next, providing the missile with a constant sense of orientation and position without the need for external signals. Fiber optic data links are manually connected, allowing for instantaneous communication between the missile sensors and its onboard artificial intelligence flight controller. Light-speed data transmission is crucial for a hypersonic vehicle, where even a millisecond of delay could result in a significant deviation from the intended target. Advanced simulations test the AI's ability to adjust its trajectory in real time, or allowing the Fattah 2 to bypass sophisticated enemy air defense systems with ease. This maneuverability is what makes the Fattah 2 so deadly, as it can change its course at any moment during its hypersonic glide phase. With the digital brain fully programmed and tested, the guidance unit is ready to take command of the most advanced missile in the world's arsenal. The focus now shifts to the hypersonic glide vehicle's nose, where specialized robots wind carbon fiber threads to create a heat-resistant ceramic shield. This composite material is engineered to survive the plasma layer that forms around the missile when it exceeds 5 times the speed of sound. The nose cone is placed inside an autoclave, where extreme pressure and heat will fuse the layers together into an incredibly strong and lightweight structure. Temperatures inside the chamber exceed 2,000 degrees, simulating the harsh conditions the missile will face during its re-entry into the lower atmosphere. After hours of curing, the carbon-carbon composite nose emerges, possessing the strength of steel but at a fraction of the weight and much higher heat resistance. Maneuvering fins made from exotic heat-resistant alloys are attached to the base, providing the aerodynamic control needed for the vehicle's high-speed glide. High-torque actuators are tested to ensure the fins can withstand the massive aerodynamic forces without buckling or losing their precise alignment. A diamond-tipped tool performs the final sharpening of the nose tip, creating an edge so fine it minimizes drag and maximizes velocity. The completed hypersonic glide vehicle nose is a marvel of material science, ready to lead the charge at over Mach 15. The final assembly phase begins in the main hall, where the massive modules of the Fattah 2 are brought together for total integration. An overhead crane gently maneuvers the primary booster into position, a delicate operation involving several tons of high-precision aerospace hardware. Alignment is critical. The engine and the fuselage must meet with perfect precision to ensure stable flight and effective thrust transfer during launch. Synchronized robotic systems simultaneously tighten dozens of high-strength bolts, creating a bond that can survive the extreme vibrations of the initial boost phase. Every bolt is torqued to an exact specification, recorded by the system to ensure that no single point of failure exists in the airframe. The deadly warhead, contained within its glide vehicle, is integrated into the front of the booster, completing the primary silhouette of the weapon. Highly skilled technicians perform the manual connection of data cables, ensuring the brain of the missile can communicate with every control surface and sensor. Fuel lines are double-checked and secured, a final manual step to ensure that the massive energy required for flight is delivered safely and efficiently. The full scale of the Fattah 2 is now visible, a sleek and formidable machine that represents the pinnacle of modern hypersonic technology. Final locking mechanisms engage, securing the various modules into a single, cohesive unit capable of withstanding the rigors of atmospheric flight. A specialized radar-absorbent coating is applied, giving the missile its signature matte black appearance while making it nearly invisible to enemy detection systems. Dimensional accuracy is checked one last time, ensuring that every curve and angle of the airframe is perfect for maximum aerodynamic efficiency. The testing phase begins as a high-intensity green laser sweeps over the missile, verifying its external geometry against the original digital blueprint. This morphological check ensures that the manufacturing process has not introduced any deviations that could affect the missile's flight stability at high speeds. Powerful X-ray imaging allows our engineers to look through the titanium skin, inspecting the internal welds and connections for any hidden defects. Every internal component is scrutinized. This non-destructive testing is the only way to guarantee the reliability of such a complex and powerful system. The control surfaces undergo high-frequency vibration testing, simulating the intense turbulence the missile will experience as it breaks the sound barrier. Static stress tests ensure that the structural joints can handle the massive G-forces generated during the missile's high-speed maneuvers. In the absolute silence of the calibration room, the onboard sensors are fine-tuned to ensure they can detect the slightest change in environment. With all tests passed, a final quality seal is applied, and certifying that this Fattah 2 meets the highest standards of aerospace engineering. This hologram represents the culmination of thousands of hours of work by the world's most talented scientists, engineers, and technicians. Standing ready and imposing, the completed Fattah 2 is a testament to human ingenuity and the pursuit of ultimate speed. With its name and origin proudly displayed, this weapon is ready to take its place in the history of strategic defense technology. The Fattah 2 leaves the facility, a masterpiece of modern engineering ready to redefine the limits of speed and power in the hypersonic era.